Hello there. It's time once again for your program, The Young Inventors, a program that offers you fun and education. I just hope you are still watching and enjoying yourself. I'm Treasure Abasi, your host, and I'll be right back after this time out. Okay, let's go. Last week, we brought you a series of projects with the concepts of alternative power source as the basic theme, running through most of the projects. Today, we'll feature a number of fresh project entries in the areas of solar security and water treatment.
The first position, junior category, goes to Abia State.
NTA Educational Television invites entries for the 2011 National Children's Expo in Science and Technology, Arts and Crafts. Interested participants between the ages 6 to 12 for junior category and 13 to 21 for senior category, whether in or out of school system, individually or as a group, are invited to submit their entries. Competitions at the state level will lead to the event of the grand finale on Thursday, 16th June 2011 at the NTA Arena, Area 11, Garki, Abuja. The Expo 2011 explores themes in science, arts and crafts, science and technology, provision of energy for sustainable agricultural development, while arts and crafts, innovation in housing and environment for sustainable greener environment. Arts, Science and Technology Expo 2011, provision of sustainable agriculture, housing and energy for national development.
This solar-powered digital DC to AC inverter and a water turbine are two project entries in the senior category from NTA Abia State by Collins Pop. He explains the principles and concepts behind each of the projects.
My name is Collins Papin from Dorothy International Secondary School, Abia State. What we have here is a solar-powered digital DC to AC inverter. This project is aimed, and this is a water turbine. Both projects are aimed at production of electricity at a lower and less effective cost. The principle of operation of the solar-powered digital DC to AC inverter, it works under the principle of the solar panel being able to trap the sun's energy, converting the sun's energy to DC current. The DC current converted by the solar panel is then stored in the batteries. The batteries have the ability to store charges, and this is the oscillator unit. The oscillator unit does the main conversion of the DC current to AC. This is a transformer which amplifies the AC current that is being directed from the oscillator, which gives DC current to the oscillator, which gives AC current to the transformer. The transformer, in the sense, amplifies the AC current that is given by the power transistors.
Okay, how does it function? Can you show us how it functions?
Okay. With all these connections done well, you can see that this is the black wire indicates the negative terminal, and the red here indicates the positive terminals. The oscillator unit properly placed and the power transistors. You'll find out that since the solar panel is open, the red LED here shows that it is being charged by the battery. When the system is switched on, the blue LED shows that the power is on, and then with a load applied on it, you see that the AC current is being, the DC current is being converted to AC current, which is used by most home appliances.
Okay, now tell us, what are the materials you have used to put this together? And this is a prototype. What was the reality? About how much you think it will cost? Okay, based on the solar panels and then how many light points can it carry?
The materials used in the construction of the project include simple electronic material, which include the resistors, the capacitors, the transistors, the transformers and switches. In reality, when this is a prototype, if you want to have a bigger inverter that can carry your loads, you have to first calculate the amount of load you have in that building. With the amount of load calculated, you then you increase the power transistor. With this power transistor increase, you find out that the amount of current that is given is increased. You increase the size of battery to increase storage efficiency. You also increase the number of the size of the transformer to increase the capacity of it to boost the AC current. Also, the solar panel is also increased to aid recharging the batteries, which is charged by the sun's energy, which is an inexhaustible source of energy. What we have here is a water turbine. A water turbine is simply a project that enables the mechanical energy of running water to be harnessed into electrical energy. In the absence of water here, the water is supposed to pour into these cups, rolling the cups here, yielding mechanical energy, and the mechanical energy yielded by this wheel is converted by the dynamo to electrical energy.
So now, in the absence of water, how do you get it to function?
Now, in the absence of water, you can use a hand wheel to rotate this wheel, which, when the revolution per minute is reached by these wheels, you find out that there's DC current that is produced by the wheels.
So are you telling me that water placed in all these cans will roll this thing as fast as you have done?
Yes.
How do you think that is possible?
Since the revolution per minute of these cups here and the wheels placed and calculated, you find out that with the velocity ratio of this, you find out that water placed at least at a height of 200 meters can roll these cups as fast as I did now. You can find out that I've tried to replicate in this prototype is simply a hydroelectric plant, which is similar to what we have at the Kainji Dam and the Ishibura dams we have in Nigeria. This is also an alternative for provision of electrical energy in Nigeria.
How old are you? Where are you from?
I'm 16 and
are you in secondary school?
I'm in Dorothy International Secondary School and I'm 16 years old.
Also from NTA Kaduna in Kaduna State comes this water treatment project, entered in the senior category by Jennifer Bader. The upcoming lady engineer explains the principles behind her both projects and how she put them together.
My name is Jennifer D. Baidu, a student of Girls Science Secondary School, Suba, representing Kaduna State. Here with me is a device titled water treatment device. At this side here, we have the container that contains the dirty water or the impure water. Here is the tap regulator that when we on it from this place, the water goes down into the pot here while it boils. Here is a combination of chlorine and iodine. When I open this place, I allow my mixture to come down in drops. As it goes down in drops, it reaches to this T-junction and then it mixes the water and goes into the pot. Here underneath the pot, we have a stove that contains coal. Here, I have a stove that contains coal. I'll on the engine and then it blows the coal instead of me using my hand, and then it generates heat that boils the water. As the water boils, the steam that goes up goes through this place. That's the heat resistant tube. As it goes into this place, it goes down into the condensed container. This is a condensed container. Here, the water condenses, it collects the water, and then I apply ice. Here, the water, that's the steam that goes from this place, goes into this place, while I apply ice inside to cool the water down. As it cools down, why I open this place is, if I close it like this, the water will not it's not going to pass through, and the water is going to explode. And when it explodes, it will cause injury to me and the person watching me. While I open it here, then as I put in as I put in my ice, it cools the water, and then here I open the tap. When I open the tap, the water comes down, and it comes down as drinking water. In this process, I can get two types of water. That's either drinking water or distilled water. But I will get distilled water when I close this tap. Then I open my tap regulator. Here is tap regulator. I open it and I allow my water to pass through this tube. Now the water is passing through. Here I open the mixture of chlorine, fluorine and iodine. As you all can see, close it. Now it mixes here with the water at this T junction.
Can we open this thing? This compartment? No.
Yeah,
You
no,
can't open
no.
the pot. Okay.
Because of the steam.
Okay.
So it passes down here and then it mixes with the water and goes into the pot. Now here inside the pot, now we're going. Okay, our fire is not yet
No,
off.
just put it on.
Okay. This receives air through the aid of pressure and it passes it to the coal and then it on fire.
Okay. Then of course that fires this and then the steam is what comes here.
Yes, and then condenses.
Good.
Now it's boiling. So we wait for it to boil.
Yes. When it boils, what happens?
Okay,
That's
as it
what I want
boils,
to
when it
conclude.
boils, the steam passes through this heat resistant tube into the condensed tank. And as it reaches into the condensed tank, I continue putting in my ice as it passes through and then I open the tap.
Apparently showing their concern for the problem of security in our society, these group of students from NTA Port Harcourt in Rivers State have come up with a multi-purpose security alert system.
My name is Long John Tamna Mesia. My teammate here is Donzukali Gichugu. The title of our project is Security Alert System and also the windmill generator. For the security alert system, the materials needed are battery, which can be alternated for solar system. We are looking at the cost here. We also need a switch, the alarm. We need the speaker. We also need the bulb. How does this project work? When the transducer has been depressed, which contains the negative panel and the positive panel. When it has been depressed, it then sends the current onto this thing, and if it's being switched on, when the batteries are put together, it can put on this light and also the alarm. The aim of this project is to reduce the security lapses in Nigeria. It could also be used personally at homes for checking of theft and other things that are due to security lapses at home. It also could be used in zebra crossings so that when this is depressed, it can make the traffic lights turn red and cause vehicles to stop, enabling people to pass. It could be used in zebra crossings. It could also be used in large organizations. This could be kept in their security post, and this in the boss office or in another place. This is the windmill. It works with wind. It's usually mounted in deserts where the air pressure is very high. It is just a prototype. It's usually as tall as that with the turbine. It works with the use of air. It can't work here because of the air pressure is very low. When the wind makes this turn, it then moves into the dynamo, and when it comes in contact with the magnet, it can now generate electricity. When that is now depressed, and this is put on, this will bring down.
Put it on.
It's on. The light is on.
This light.
Let's hear the alarm.
This is for the light, and when you put it on, it's for the alarm.
Also towing the line of security something for the Expo 2010, Jalal Zakat presents his security device meant for use in residential buildings. The project is entered in the senior category from NTA Bauchi States.
Now, what is this project all about?
Me wannan yake magana akai.
Shi yana magana akan wajen tsaro.
The title of the project is for security purpose.
All right. How does this project function? How does this security system function?
Ya ake yi aiki, ya amfani.
Akan shiga a kwanta, a tsira, a ajiye abubuwa a ciki.
Okay, it is used for a person to
to go inside and sleep, so that for security purpose nothing will happen to him. And we used to store some of our goods materials as well as our capitals.
All right. What are the basic components? What are the items you use in building this project?
Me da me kan amfani da shi wajen yin wannan gidan haka.
Na samu carbon paper.
He used cardboard paper.
I use sawdust to make na samu sawdust hada wannan abu sawdust.
He used sawdust to make these flowers.
Na samu leda ne hada window da winduna da kofofi.
He used a leather, transparent leather to construct the windows and the doors.
Wannan kuma shi soso ne abu.
This one is mattress. Some part of the mattress he used.
Wannan kuma shi kuma swimming pool ne aka saka leda aka saka transparent aka saka blue.
This is a swimming pool. He put leather under it, then it's just recognized as swimming pool.
Okay.
This is car park where we used to park our vehicles.
Now, how does this whole system function in terms of security?
The light will be on.
So with these lights now, it then illuminates the environment.
Yana amfani a haskaka ko ina cikin.
Yana haskakawa inda dare na haskaka ko ina.
From NTA Yenogwa in Bayelsa State comes this automatic power changeover in the senior category by Mercy Fred.
I'm from FGC Mengi. I'm presenting Bayelsa. And the title of my project is an automatic power changeover. From this gen neutral, let's say we don't have PSN supply, there's no voltage. From the gen neutral and the gen life, it moves over to the load neutral. And from the load neutral, we move over to the PNCN light when the light comes. And from PNCN life to the PNCN neutral, it moves over and current is being carried out down to the power pack. And when it's carried out to the power pack, it releases 12 volts to the operating coils. And from the operating coils, the electromagnetic flux takes place. And from there, it attracts this current and it moves from 2 to 1. And from 2 to 1, the current is being moved to the load life. Then we have the PSM supply. So from the PSM supply, from there, the current is going to move to the gen and to switch up our gen. Then we'll have the power supply.
What you are saying is a changeover kind of situation.
Yes, sir.
Why did you do it? What is the essence of it?
It's because of safety purpose. In case you can't go outside, maybe in the night, from burglary attack, you can't go outside to put on your gen. Immediately there's power failure, the gen will on by itself.
So where is the practicality of it here? Can you just show us? Even if it won't work, let's see.
Since we don't have the gen here, we have the gen wires, the PSM wire, outputs, and then this is the load life, where we have the PSM. Then here is for connect the generator.
So, what happens?
From here.
What you have explained there, just explain it there.
From here, this is the gen life. When we put on the gen, you see, there is light now. So when the gen goes off,
put it again. Put the gen.
We have the gen now. So when the gen goes off, immediately we have the PHCN supply. This is it. Immediately there's power failure again. Immediately the gen comes up by itself. This is it.
Who says the women folk are not winning? With the likes of Mercy and Co. already making meaning with these engineering creations. Okay, so much of project's presentation.
My name is Fatima F. Mahmoud.
My name is Hassana Alifa from Mariam Babangida Girls Science College, Mina, Niger State.
My name is Chinazom Ezomuna. I'm from Brightway College, North Makodi, Benue State.
My name is Akindele Oluwadamilola from Christ General School, Ado Ekiti.
This is a simple key that we're going to use to talk about expansion of gases. We're going to see, like I said, Boyle's law, Charles law, and as well as the kinetic theory of gases. We see the explanation inside this particular simple experiment. Yeah, what do we have here? Sorry, who can tell me the name of this? Sorry, by the way, yes, thank you, manometer. It's a YouTube manometer. So you can see I have colored water inside. We have colored water here. The colored water is for us to take measurement when if the gas expands. We see that here now everything is equal. There's no movement either up or down because everything is equal. The pressure outside and inside is equal. But now we want to see something. Now, like I said, when you have a closed system, there are some parameters that affect the pressure of the gas inside. One is the volume of the container, and that one is the volume of the gas itself, and also temperature. Thank you very much. So we're going to look at all these factors now. First of all, we want to look at the volume of the gas itself. That is the density of the gas. Here now, I want to use this my syringe to also collect. I have, air is a gas. So I have a gas here now, and I want to fix it here. Mind you, this my particular container is inexpansible. It cannot expand. So I'm going to depress this plunger. I want you to observe what is going to happen at these two units. Hello, what do you observe? Where? Can I explain what is happening now? Can you explain?
Actually, the air inside, because it caused the liquid to move upwards. That's showing that air occupies space.
Okay. Any explanation?
Or increase the pressure.
Good. Yes. When we have a fixed quantity of gas inside, we now added more of the gas inside the container, and this container cannot expand. In other words, there's increase in the pressure of the gas. Because their pressure have increased, they tend to expand. They are not expanding, and they are looking for a way to escape. Because they cannot break away from this particular container, they are now pushing this water upwards, showing that the pressure inside is more than the pressure outside. That's why the water is going up. Is that clear? Good. Okay, let's again observe. You can see the thing has balance now. There's an equilibrium. Good. So let's go on. Okay, this has to do with the density of gas. Now let's look at volume. When volume increase, like I told you, we explain Boyle's law and Charles law here now. You can see this. I want to put an additional volume here, and I'm going to increase the volume. What did you observe? Good. So you can see that because I have increased this volume of the container without increasing the volume of the air inside, the pressure decreases. So the one outside is more than the one inside, and you're pushing the gas inside. So this has to do with Boyle's law. When you have what pressure and the volume is inversely related. This is Boyle's law. Good. Let's going to see the effect of temperature. We are going to close this, make this in a closed system now, and we want to apply heat using this our simple. So the light is on. Yes. Let's observe what is going to happen now. You find out that this is a simple explanation of the kinetic theory of gases. One of them said that if one is that they occupy the shape of the container, the other one said if there is increase in their temperature, what happens? There will be increase in their velocity. They will tend to move and bombard with the walls of the container, and that will increase their pressure.
I hope we have thrilled you as much as we have educated you. If you join us next week, same time, same station, we'll bring you a fresh edition of the program. Bye-bye.
The first position, junior category, goes to Abia State.
The NTA Educational Television invites entries for the 2011 National Children's Expo in Science and Technology, Arts and Crafts. Interested participants between the ages 6 to 12 for junior category and 13 to 21 for senior category, whether in or out of school system, individually or as a group, are invited to submit their entries. Competitions at the state level will lead to the event of the grand finale on Thursday, 16th June 2011 at the NTA Arena, Area 11, Garki, Abuja. The Expo 2011 explore themes in science, arts and crafts, science and technology, provision of energy for sustainable agricultural development, while arts and crafts, innovation in housing and environment for sustainable greener environment. Arts, Science and Technology Expo 2011, provision of sustainable agriculture, housing and energy for national development.